right. Thanks everybody for joining this animated art workshop. It's going to be a pixel art workshop like my last one, but this doesn't have to be um, confined to just pixel art. It's just it's makes it a little bit easier in some ways that I'll go into as we go through it. But um, this can actually work for any kind of art that you want to do. Set up a sort of looping animation for. This is a really like kind of particular process that I've created. I don't know anybody else who's done this, but it's helps me automate some of the more annoying parts of it, um, and avoid some of the things that certain apps like After Effects will do that actually do run kind of counter to the pixel art look that I'm going for. Um, and I'll explain that a little bit as we go through as well. Uh, so for those of you following along at home, there should be some links in the description to set up for Phaser, which is it's a JavaScript game engine that I'm using here to do the automation of the animation basically. And they have some really good documentation on how you can set up a server locally on your development machine so that you can run this code locally. You can't just download an an HTML file and run it just by double clicking on it because your computer needs to be able to protect itself from all this code that's running on it. So it has to run inside a server, so it's kind of boxed in and behaves the way a web server would. Um, so I won't go into how that works right now because it's kind of complicated, and the documentation I think covers it better than I could anyway. So um, I'm also going to be using Photoshop. You don't have to use Photoshop for this. I know a lot of us have access to it, so it's probably pretty familiar. But you could use all free tools for this if you want, or other image editing platforms. Um, but yeah, I'll be sticking to Photoshop just for simplicity's sake. So let me show you a quick example of some of the kind of art that I'm going to be creating. Some of the stuff I've done in the past. You can see this all on my portfolio here. Let me make a good example. So this is check out the animated tag on my Tumblr site here, and you can see all the stuff I've done before when it loads, which it will eventually. This is really slow. Oh wait, there it was. It was there for a second. The second I try to stop loading, it shows up. Okay, let me try going to my site, which is actually loading the same data, but that always seems to work a little bit better. Here we go. Okay. So all of these are animated GIFs or GIFs, as suits you, that I've posted to Tumblr. Uh, I use that format because it's long been a really popular format for simple animated images. Um, Interestingly, a lot of platforms, I think Tumblr included, are actually secretly converting these to video formats behind the scenes. So it doesn't have quite the utility as a file format as it used to, but when you upload it to one of these services, the same thing goes for Twitter, I know, and probably for Facebook as well, and other sort of social media spaces. Um, at least you know that it's going to try to treat it the way one of these traditional images works, and just kind of endlessly loop the same series. So if you want to post to Instagram, you have to manually convert it to a movie, though, and I'll talk a little bit about that at the end. If posting this stuff is important to you. Um, in my case, though, I kind of started doing this with pixel art because pixel art lends itself really well to the limitations of the GIF format, since it's only allows up to 256 colors, I believe. Maybe you can do more. I'm not sure actually if it limits the number of colors, but basically the file size increases a lot the more colors you allow. So it's really good for images that have a very small number of colors, very limited palette, and where the looping animation is pretty short. So that lends itself well to pixel art and these kind of old-fashioned video gamey kind of compositions like this. It's also nice because just sort of the expectations around the art are that it's not going to be super fluid or detailed. It's just kind of expected, since people remember this from old video games and stuff like that, that it's going to be very simple animations without a lot of frames, and it just kind of looks right in that regard. So it allows you to do things relatively quickly. And as you'll see, a lot of these images I've done here just kind of have these overlapping layers of movement, and these are just tiled layers moving, in one consistent direction the whole time. Um, this one's a pretty good example right here. I think I just heard a bloop. Did somebody have a question? I can't see Discord right now if anyone's talking to me. Anybody? Can you hear me?
Yes, we can hear you.
Okay. It was definitely a Discord blip. I think someone sent me a message and I can't read it right now. Sorry. So anyway, sorry, person. Hope it wasn't urgent. This image right here is actually kind of what we're going to be doing today. We're going to be taking this artwork that I've created that I've not yet made into an animation, and we're going to do basically what I'm doing here. We're going to have a few layers of motion that are going to be moving at different speeds to suggest perspective. That's called parallax. You might probably heard that before. And we're going to also have a simple little kind of looping sprite animation where rather than moving a texture, we're swapping between a few different frames of the same thing. And in this case, it's just going to be a single light that goes on and off. So it's actually really just like either the image is visible or it's not. It's going to be a really, really simple animation. And I like to stick to those kind of things because they're pretty easy to do, but they give a lot of sense of movement and atmosphere to the images. That's what most of these are doing, are just kind of. This one was more complicated. I actually had to do some sprite animation for it, so we won't get into this. Same thing with this one. But I'm trying to think. This is another good example where there's just a little bit of movement. That one doesn't even have any parallax. This one's got some parallax as well. So essentially, all I'm doing with these images, actually, let me go back to this one really quick. All I'm really doing is I have this this texture that's tiled over the whole thing, and even though it takes a number of frames, for example, for this what looks like this snowflake right here that I'm kind of hovering my mouse over. Can you see my mouse?
Yes.
Okay, great. Um, it looks like the whole thing is going all the way down the screen, but it's actually a trick because since it's a tiled texture, it only has to go down, about a quarter of the screen, I think, or maybe it's half. I can't remember, and then it will just sort of loop seamlessly around. So you'll see what this means when we get into it. But basically, you don't actually have to animate all of the frames that are required for one of these snowflakes to go all the way down to the bottom of the screen. You just kind of need to trick the eye into thinking it's happening, and that lets you keep your number of frames low, and that keeps your file size low. And this, if you only want to post to Instagram or only want to do videos, by the way, file size does not matter because you're just going to be doing video. But if you want to keep it as an image file, then that can be important. So, I used to do this all manually, by the way. This one, for example, I did this all in Pixaki on the iPad, and it was a nightmare. I just moved these frame by frame and had to try to do the calculations in my head to make sure they were all moving the right direction and the right number of pixels per frame, and it was awful. So that's why I started using Phaser instead. So Phaser is, like I said, it's a JavaScript web browser game engine. It's meant for video games, but that means it has a lot of built-in tools for manipulating images and animating them over time. And you can use it in this case for just that. I'm not doing any of the other game stuff that's built into Phaser. So there's actually also ways I could do this, probably using much simpler libraries. I know Phaser for a long time was built on the Pixie.js library. It might still be, and I could just use that directly if I want. In fact, I might change it so that I do that. But for now, this is something that I'm pretty familiar with. So I just spent some time working on it for a game. So it was just an easy thing to jump into as just a way to automate things. So this is the HTML file I've created. And this is just an example. You can actually download the images that I used, which are not the same as these images, by the way. But you can download some sample images, load those into the same folder as these, and if you're running a server, you'll be able to actually see this. It's just a very simple cloud movement, not unlike what we're going to be doing here. So we're going to be changing this a little bit as we go through just to make it work for this. So let's start off with our image, though. So first, we have to prepare this image for what we want to do, basically. You can see over here, this might look pretty small because my screen's kind of gigantic, but you can see I have 10 different layers here, although we're not going to actually export that many. I have this kind of background sky layer. I've got some stars and moon halo effects and things like that. So basically what I'm going to do is I'm going to take everything below this image here, or this layer here rather, like this whole background. I'm just going to save this as a single static file. This won't move at all. It'll just be the background image. I'm going to try to save everything at the exact same size. This image is 256 by 256. You don't have to do that because Phaser is going to allow me to move the images around the screen, but it just makes things a lot easier right now. I know that it's already lined up visually the way I want it to be, so I don't have to worry about it if I just make everything the exact same size. So I'm going to go ahead and I'm just going to save this as a PNG. Nope, I'm going to export it as a PNG. Wow, this is complicated. I don't need anything like this really, but so I'm just going to keep all the default settings. I'm going to save this to my desktop where I've created this index.html file. Oh yeah, by the way, I downloaded this gist and I created an index.html file on my desktop. I'm going to run the web server on my desktop since it's otherwise free of files. You need to make sure, well, I guess you don't need to make sure it's called index, but that'll just make it easier for it to come up quickly. So I'm going to call this sky. Okay, cool. All right, so now that I've done that, I can start working on these. Now, the tricky thing here is, so I have these different layers of clouds, right? And what I'm going to be doing is have the clouds all move past the camera, quote unquote. This pyramid shape, this like futuristic pyramid is going to be in the front and it's not going to be moving, but I'm going to have a little blinking light on the top of it. So that's the plan. So what I need to do now is I need to make sure that I want to keep my overall frame rate low. So since the background layer of clouds will be moving quite slowly compared to the front ones, I don't want to have to make hundreds of frames of animation in order to wait for this entire screen's worth of clouds to move off. I'm going to have them move from right to left here. And the amount of time it would take this to move all the way there slowly and smoothly, it's going to depend on my frame rate. But let's say we want to do this at like 24 frames a second. And the whole thing is 256 pixels wide, right? So if I'm moving that, let's say I want the whole animation to last like, I don't know, 12 seconds. Like it takes 12 seconds for this side of, the cloud over here to completely move off the screen on this side. So that's going to be 12 times 24, so 288 frames. And that's quite a lot. That's going to make the file pretty big. I'd rather have it be something more like 64 frames and try to keep below that. So what I'm going to do then, this is where you have to do some math. And the great thing about this math is I always forget how to do it. I have to kind of rethink it on the fly. But essentially, what I need to do is I need to create a tiled pattern for these clouds in the back. And because they're farther away and they're going to be moving more slowly, I have less space to work with. I need to do more repeats, essentially, if that makes sense. It's sort of counterintuitive, but ideally, let me see what I have my grid set for here. So my grid is set at, it's set a percentage, which I don't want. Let's set this for every 64 pixels, right? So I'm just going to, actually, let's do 32 pixels. So if I'm doing 64 frames, yeah, take that back. Let's do 64 pixels just to keep the math simple. Okay, so if I have a 64 frame animation and I want to move this background layer 1 pixel per frame, so that means it's going to be going about as slow as I possibly can. I can technically move it less than that. I can move it at subpixels, and Phaser will kind of try to blend the image in a way that it like sort of, even though these are, very blocky pixels, it'll sort of try to come up with a distance. It's going to look something like this. I can kind of imitate it by putting a semi-transparent thing over here. Oops. It'll look sort of like that. Like it'll start blurring the edges. And this is what I don't want. Since I'm doing pixel art, I want it to look really crisp, and I want it to move in discrete pixel units because that's the only thing those old computer displays could do. They didn't have the ability to interpolate between pixels. So I'm trying to imitate that as much as possible. If I don't do that, it's going to look a little weird. It'll look kind of blurry and strange. So that means I'm limited by the slowest I can move any element on screen is basically 1 pixel per frame. Or what I could do if I want to get a little fancy is I could like move it 1 pixel every other frame, but then it's going to look very choppy, and I don't really want that either. So we're just going to put that as our lower limit. So since this is a 64 frame animation, that means that this can only be 64. The pattern has to be 64 frames wide. And then that's repeated 4 times over the course of the image. Everyone following me so far? Take that silence as a yes. Cool. So I drew this all freehand. I kind of tried to make it look a little bit uniform just to get a sense of what it was going to look like. But now I'm just going to straight up copy that first segment there over the entire image so that I know it's exactly identical. And the nice thing about pixel art is that I can kind of get away with that. You don't really see the seams the way you would in higher quality art. You'd have to be a little bit more careful to make sure that this really lined up with this edge in a way that looked natural. Pixel art really, it's pretty forgiving in that regard. So I'm just duplicating the layer here. Okay. And then I'm merging the layers after that. So I have one single layer. And now this is, you can look at the grid here and see that this pattern is repeated exactly every 64 pixels. So let me show you what that actually looks like once we start putting it into the little phaser, the mini phaser app that I've created. So I'm going to save this whole thing. I'm not going to quick export as PNG because if I do that, then it will automatically trim off the empty pixels at the top there, which is actually good for optimization because then you're not saving a bunch of useless space. But it like I said, it's simpler if I just keep everything the same size for now. So I'm going to go ahead and export it, make sure there's transparency, which is default. And I'm going to call these, I have 4 layers of clouds here, so I'm just going to call it cloud 0. And I'll just count up from there. Clouds -0. You can call these whatever you want, it doesn't matter. Now I'm going to go ahead and I'm going to jump over, oops. I'm going to jump over to my index file, and I'm going to open up. Well, first I'm going to start the server. Okay, so in my case, I'm on a Mac, and Mac actually ships with a built-in Python 3 server that you can use. I can post how you do that. I think Phaser actually mentions that as an option. So that's nice and simple. I don't think you have an option like that on Windows, so you have to use one of those other ones that they have, but they're usually pretty easy to set up. So I'm going to my desktop here, and I'm just starting the server. I have a little shortcut for doing this since I'm a developer and I actually need to do this on a somewhat semi-regular basis. So, so you can't just do this and type HTTP. I have that set up as a shortcut, but again, you're going to do your own server setup somehow. So PhaserDoc should help you through all that. So this is now serving up the a local website on port 8000. So when I open up my browser and I go to localhost 8000, cool. It is now showing this pattern here. So this is directly as I copied it off of that link that I showed everybody. I'm gonna just increase the size of the screen here, which is a nice way to just blow up the whole image while keeping all the file sizes down. You can also there's ways you can scale this automatically to the screen, but I don't want to deal with that right now because I just need to preview it and make sure it looks basically right, and then I'm going to be downloading all the images for the final version. Any questions on all this so far?
I just posted the Mac command in the other stream chat, by the way.
Oh, great. Thank you. Cool. So what's actually going on here is my little example assumes you have these 4 PNG files locally, which it doesn't. So Phaser is indicating that there's a missing texture here with this, and it's moving that past the screen, which is kind of cool. So you still get to see it. So I already have this animation loop set up essentially. So I'm going to remove all this. And let me just go through the code a little bit here, just to hopefully, I'm not going to go into too much detail about exactly how it works because you don't actually need to know. But just so you're clear. So right here at the top, if you've done any work with HTML, you know that you can load JavaScript scripts from remote resources, which is what I'm doing here. So I didn't grab like a local installation of Phaser. I'm just pulling it directly from their CDN, their content delivery network. And that allows me to use Phaser in this on this page anywhere I want. It's very simple. So that's just this is me saying, hey, load Phaser in so I can use it. This is some description of what's going on. And then basically what I do is I create the whole body of this HTML file is just this one script. There's nothing else here. Phaser is automatically going to create the canvas or the WebGL. It actually uses both, depending on the browser. The element here that contains your game, quote unquote, so I don't have to worry about that. And the way you do it is you create this little config object. This is telling me that this is where I tell it how big the screen is, which is going to be the same size as my image, 256 by 256. I have this thing set here to round pixels. This is kind of important because that means that if anything on screen is at like a percentage of a pixel in a certain direction, it should just be rounded off to the nearest pixel, which is how I get that crisp pixely look that I want. And again, you don't need this necessarily if you're doing higher resolution artwork, but I would start with pixel art just because it makes this a lot easier. This is some stuff that's just telling it where I've basically placed all the logic that it's expecting. It's expecting a preload function, a create function, and an update function. So I'm just telling them that they exist. They're down here basically. And here I'm setting the frames per second. I'm setting the target to 24. I forget what force set timeout does. I think that makes sure it doesn't exceed 24, but I can't remember. I know I put it in there. You'll notice that there's the commented out. These are comments, by the way, these little two forward slashes, meaning that this is just little notes that I can put in here, or it's code I can put that's disabled, so it doesn't get evaluated. And you'll notice I say change frame rate to a very low value when exporting frames, and I have target 2 set here. This is important because right now I want to see what the animation actually looks like, but when I enable the code that's going to download all the images and allow us to export them, you need to do it really slowly because otherwise it will just do its best to keep up and it will skip frames and you won't get everything. So I find 2 frames a second is pretty good. You might be able to go a little faster than that, but it's not a huge deal because you just have to wait. Right here, I'm creating my Phaser game, quote unquote, with that config file that that little config block that I just defined. And then finally we come to the stuff that we actually need to edit. So all that stuff above, I mean, you might need to change the sizes depending on what you're doing, but you probably don't need to change it if you're just following the tutorial exactly. So the important thing right here is the preload function. So this is where it loads in all the images. The images have to be local. You can't pull them from like a remote server because they need to be bundled in with the game, quote unquote. So in this case, none of these exist, so I'm just going to get rid of this. And I'm going to change this first one to, I'm going to load 2 images. I'm going to load that sky and cloud 0. We'll start with sky. So when I load it here, I'm doing this little bit of code here. This.load.image. This is, basically like the game, essentially, this game that I've created here. So you'll see that a lot. And that game is a whole big blob of code that Phaser is giving me that I can use to do stuff. In this case, like loading images are functions that are available on this because this is a game that Phaser has defined. So these are all basically like helper functions that Phaser has defined under the hood that you can just kind of use to do things quickly. So when I do this load.image, I'm giving the image a name, and then I'm telling it what the path to the image is. In this case, it's the same folder, so I don't need to give it anything more complicated than that, but I could also do that if I want to be more explicit. Anyway, so we're going to load the sky, and then I'm just going to copy and paste this, and I'm going to load clouds 0. So this just makes sure that these images are loaded into memory. It doesn't do anything else. It's not going to show them on screen yet. They just exist, and the game can now do stuff with them. So when we get down to create, now we start doing that stuff that I'm talking about. So I'm going to, all right, I'm going to just delete these, and I'm going to rewrite these 2. So I'm going to call this dot sky and this dot cloud 0. Oh, it doesn't like that. Do a dash. Nope, I can't. I shouldn't have called it that. All right, that's fine. So it's a little confusing. I'm not being consistent. Here I've got a dash. Here I don't because JavaScript doesn't like there being a dash in variable names, but that's fine. So what I'm doing here is I'm creating, these are either, what are these, instance variables, I think? So these are variables I'm creating here. I'm creating one called sky and one called cloud 0. I'm defining them as the image that I'm actually adding, and this is actually adding the image to the screen here, basically. So this code right here is going to add the image, and this code right here is going to keep a reference to that image so that I can play with that image later and do things like animate it, basically. It's going to be available in other functions besides right here in create. So right now you see these are like functions. You see function preload, function create. These are sort of discrete blocks of code that get called at different times by Phaser itself. And they have this thing called scope, which I won't get into, but basically like the reason I'm calling it this dot sky here is so that I can reference it anywhere in any of these functions. Now, basically anything that's part of the game, which is what this refers to, is going to be able to do stuff to this dot sky or this dot cloud 0, essentially. So don't worry too much about the specifics of this, because again, I'm just trying to demystify it a little bit, but if I'm making it more confusing, you can ignore this. So what I'm doing here is I'm changing this, but I'm still keeping most of the logic. So I'm adding an image. That's a built-in function that Phaser gives me, so it's going to actually put it on the screen. I'm setting the image's position at 0, 0. And then I'm telling it to add sky, which I've already defined here, so it knows it's the image that it loaded from this file. And then I'm doing this little thing here, set origin to 0, 0, which you don't have to do, but by default, Phaser images, I think you may have seen this in Photoshop. I think you're probably familiar with it, but like if I go into Photoshop and I like, for example, I transform, actually this is a great example. This is actually wider percentage than the screen, although I didn't know that until I tried to transform it. But if I try to, for example, rotate this image here, you'll notice it rotates around a central point. Because at least as far as rotation is concerned, Photoshop considers that where the image is. That's like the anchor point, basically. You may have noticed this before. So what I'm doing here, or an origin point would be another name for that. So when I'm setting the origin, I'm saying consider the location of this image to be 0, 0, which is the top left. Basically, like that's where 0, 0 is. And then the numbers increase as you go down and right, as far as the coordinates are concerned. So this basically means set it at 0, 0 on the canvas, which is, you know, this right here. This is the canvas. So 0, 0 is this point here. So I'm saying I want it to be set there, but I also want the image's center, you know, image's meaningful point, its position to be there. So basically that will line it up exactly with the canvas. That's all. So now for cloud 0, I'm not adding an image. I'm adding what Phaser calls a tile sprite, which is a special kind of image that is designed to do exactly what I'm trying to do. It's designed to offset its own texture, so it looks like it's moving. It's actually not. The image is staying in one place. It's not really moving in the game space, but the texture on the image is animating. I can move it around, essentially. So that's called a tile sprite. So for that, I have to add a little bit of extra code telling it how big it is. So I'm telling us that this is the position here, 0, 0. This is the width, and this is the height, 256 by 256. One thing that's actually really important is that these will look weird and fuzzy if this the size of the image is not a power of 2, which I know sounds really bizarre, but there's a mathematical justification for it. I don't know what it is, but apparently that's an issue. That's a problem I had on my video game. Like, but basically, like, so you always, even if you're not filling the entire screen, or rather, even if the screen size doesn't match that, it's important that this image does. So, and again, that might not matter as much outside of pixel art, but when you want to keep everything crisp, this is actually really important. So in this case, everything's a power of 2 anyway. It's 256, or 2 to the 8th, I think. So the problem's already solved for me, but that's just something to keep in mind if you're doing this by yourself and messing with this at all. So we're going to set this to cloud 0. And again, we set the origin to 0, 0. And here I'm setting snapshot count. That's not something I'm using yet. But later on, when we save all of our frames, I need to know how many frames I've actually saved, so it doesn't just do it forever, basically. So I'm just leaving that in for now, even though we're not using it. So now I'm going to go down here, and I've got a bunch of comments here, which I'm just going to remove from now because I'm going to explain it anyway. But it's trying to explain how the movement logic works and why I'm using these particular numbers. So in our case, we already talked about it a bit, right? We have a 64 pixel wide pattern, and I want to move it 1 pixel per frame. So right here in this update function, this is a really key thing in pretty much every video game engine you're ever going to use. There's always some kind of looping function. Like Unity has a version of this, pretty much everything does. There's always a function that a video game engine will call every single time it's rendering a frame or about to render a frame. And that's where most of your game logic is going to live, or at least like where you're going to start, basically. It's like, so something like, even as an old simple game like Space Invaders, like before you draw a frame, you have to move the aliens, right? You have to move the player's spaceship. You have to move any lasers that the player has shot. You have to figure out if those lasers have hit any of the enemies. You do all that basically frame by frame in the update function, and it gets much more complicated than that, of course. But like that's basically the underlying way that game engines work. They call this every single time they're about to render a frame, and then you do some logic to figure out what happened in between these frames. In our case, all we're doing is moving something, so it's pretty simple. So I'm taking Cloud 0, which is that tile sprite we created, and it has a property called tile position X. So the X value of where its like texture is, basically. And I'm just adding 1 to this. So that means it's going to move from right to left. And it's going to do that every single time there's a frame. So if I refresh this, cool. All right. Now you notice that even though because this is a repeating texture, even though like we're not waiting for this entire time, and this is actually probably longer than, well, maybe it's not 12. I don't remember what I originally said, but even though this is it takes a very long time for a single point to cross over, it's actually, you actually see what appears to be seamless movements in only 64 frames. This isn't actually an example of this yet because this is just counting up frames indefinitely. But if I were to stop at 64 frames and then go back to the start, then it would look exactly like this. You wouldn't be able to tell that it was just looping. That makes sense to everybody? I'm going to pause again for any questions. I'm assuming the silence just means like rapt attention.
My attention is rapt.
Great. Thank you. I also wanted to make sure that you could still hear me and I wasn't talking to nobody for the last like 10 minutes, because that's always possible. Cool. So now we can load in our other clouds, and we can do that. We're going to have to do the same thing to them because I didn't make them all exactly tileable. So, but now these clouds are going to be moving faster. So I can actually change the tile size of them to be something bigger. That I can basically, because since in those 4 frames, they're going to move more than 1 frame or they're going to move more than 1 pixel per frame. I can extend them as far as I want, essentially. So in this case, let's say this one, I don't want this to double the speed of this one because I think that'd be too fast. So I've got 4. So let's say, now here's where I have to start doing math, right? So if it moves 2 frames, actually I do have to double it, don't I? Really, I can't do anything smaller because I can't move subframes. So all right, well, this is gonna be a lot faster. That's okay. This might be unrealistically fast looking, but that's okay. We can also slow down the frame rate if we want. So essentially, this one's since I'm moving in whole frames per, or whole pixels per frame, I have to double the size of this particular one. If this is gonna move faster than the backward one, it can only really move at 2 pixels per frame, which means it needs to be 128 pixels wide. So I'm just gonna do what I did with the other one, delete half of it, and just copy the remaining half. And then we'll get those lined up. And yeah, that looks okay. Yeah. Again, pixel art's very forgiving. You don't see the seams as well. So I'll merge those together. And I'm going to export that as a PNG as well. We'll call this clouds 1. You'll notice I start at 0 and not at 1. That's like actually a common thing in the way computers count. Not every language is exactly like this, but JavaScript definitely is. It starts counting at 0, essentially. All right. So now this one, let's say this one's going to move 3 frames per second. And it's going to work, actually. I've been outsmarting myself here. Let's find out. If this moves 3 frames a second, then we want it to be 3 times 64 wide, or 192. So I think I actually need to make this larger. I'm going to have to artificially kind of increase the size of it in order to get this to work. All right, so I'm just not going to do that. I'm going to make my life a little easier. I'm just going to make this move 4 frames per second. So I don't get too bogged down in the math here. So if this one moves 4 frames a second, I actually don't need to change anything. It can fill the entire screen like this. I just need to make sure that it still wraps around correctly. So the way I do that is with Photoshop's offset filter, which is really handy for this kind of thing. I assume other graphics apps have similar features, but I'm not sure what they'd be called. But in here, if you go to Filter, Other, and Offset, you can do basically exactly the same thing Phaser's doing to our image right now. And you can just move it over a certain amount. So it doesn't actually matter how far I move it over, as long as it's like enough that I can clearly see where that seam is. And you can see it right there. You can see something that's a little off there. So I'm just going to go ahead and move that. And now I know these loop correctly because those were already together the way I'd originally drawn it. This is where the edge of the screen was before. So I'm going to move in, and I'm just going to grab this. Oops. I'm going to use the pencil tool so I can get a nice clean pixel line here. And I'm just going to smooth this out a little bit. Yeah, grab this edge here. Okay. That looks pretty good. Okay. And now, once again, export the whole thing as G. I'll call this clouds 2. Cool. And now I have this very close, these clouds that are quite close. These are going to move 8 pixels per second, or per frame, rather. So they're going to move quite fast. Problem is then they're going to loop a little too quickly. Actually, I guess it doesn't matter. This gives me the option of making a texture that's actually wider than my composition if I want. But now that I think about it, I don't have to. It will just make it, it'll be a little more obvious that it's looping than the other ones. But it should still work. It's just not quite ideal. So I'm going to go ahead and do the same offset here. And make sure it doesn't look too weird. That looks a little weird. So I'm going to erase this lump here. Create a dip. Yeah, make something that looks a little more natural. Go in and make sure that's the outline I want. All right, cool. Now I'm going to go ahead and export that. I'll call it Clouds 3. Great. Finally, I'm going to put the pyramid in here. I'm going to, oops, looks like I have an extra pixel there I don't want. Nope. I'm not going to do the light just yet. I'll do that in the last little thing. So for now, I'm just going to put things in as I drew them already. Similarly, I will export this as a transparent PNG, and I will keep it the same size, and I'll call this pyramid. Okay, so back to our code. I'm going to go back up to the preload, and I'm going to add all these extra clouds. So I'm just going to add 1, 2, and 3 here. Just swap out the numbers. Otherwise, the logic is the same. 3. And similarly, here I add the cloud sprite. I'm just going to add 3 more with the exact same logic, but I'm going to give them the new number to distinguish them. Make sure I'm setting the right file here. Cool. So now when I open this up, I'm going to see those clouds, but they're not going to be moving. If I did this correct. Yep. So now I just need to add the logic that moves these, and I'm going to set that at different rates than the clouds in the back. So here, I'm going to just copy this line of code a few times. So I could just move them all at the exact same speed, then they would all look like they're the same distance away though, right? So that's an option, but it's pretty boring looking. So I want to add a little bit more excitement, so I can add this. Like I said, so since this is moving 2 pixels per frame, it's going to move twice as fast. This will move 4 times as fast. This will move 8 times as fast. And then you get this, which is really, really fast. I'll probably go back and change this. But at least it gives you all the idea of how you can do this. This looks like the pyramid is now like flying through the air, or it's, you know, in the middle of some very, very strong winds, basically. But yeah, you get the idea. So now we get this impression the clouds in the background are farther away because they're moving so much slower. This making sense to everyone so far?
Yes.
Great. Cool. So, all right, let me add the pyramid. So the way this works, it's actually just adding all of these in order. Like, so since this line comes after this and this one comes after this, they just go on top of each other. So I want the pyramid to come last. I'm going to call it pyramid. I don't actually really need to get a reference to this since I'm not animating it, but it just makes things clearer. So I'm going to add an image here. Pyramid. I'll set the origin to 0, 0. Also, these semicolons at the end here are kind of a controversial thing in JavaScript. You don't technically need them, but they're usually there to distinguish like the end of a line so it doesn't get confused about where the next one starts. Whoops, and that didn't work. Oh, because I didn't load it. Ha! But handily, Phaser does tell me like, hey, you're trying to load something and it's not working. So I need to go back to my preload here and actually load that image. There we go. Let's set that to pyramid. Okay. There we go. Here's our pyramid. Here's our extremely fast-moving clouds. Cool. So yeah, finally, just to show another example of some of the other logic you can do, I'm going to add a little, like, you know, one of those, like, for planes, blinking dot lights at the top. So go back into Photoshop and actually add that. I'm going to add the background so I can see what I'm doing. Okay. I'll make it red, but about the same brightness as these colors. But like kind of, yeah, orangish red, so it's actually more like a pinkish red. It's distinctive looking. Okay. I'm going to put that right on top here. Actually, what I'm going to do is I'm going to do like a little blob. And do like a really bright color on the inside so it looks brighter. Do like a darker magenta-y color here. Kind of gives you the idea. When you zoom out, it sort of looks like a gradient. Make it a little more circular. And then I'm going to stop because it doesn't have to be perfect. It's just an example. There we go. Okay. So now oops, and I actually drew it right on here, which I didn't want to do. So I'm going to copy that, and I'm going to undo all the stuff I just did and put it on its own layer where it was supposed to be. Oops. Creating a new layer, and then I'm just going to erase the little extra edges here. I really wish Photoshop had a feature where it's like, hey, all that stuff I just did on this layer, do it on another layer. That would have saved me many tears over time. All right, cool. All right, so this once again, now this is really silly that I'm saving this entire giant, mostly empty image. But I'm going to do it just so I know exactly that this is in the exact right place on the pyramid. Otherwise, I'd have to kind of play around with it until I got it in the right spot, and I don't feel like doing that. Unless that would be useful for anybody to watch. I'm guessing not. I'm just going to call this blink. Okay. And then I'm going to go back to my code. I'm going to load that in, and I will load it last so it appears above. Or actually, not load it. I'm going to add the image last so that it appears in the right place. Blink. Blanc.png. And okay. Now when I go back to my, there we go. So now it's just there, but I want it to blink on and off. So the way I'm going to do that is I'm basically going to say like, okay, I need to figure out, this is a 64 frame loop here that's going on. And I want this to, let's say I want it to blink, I don't know, twice over the course of it, right? And it will stay on for about as long as it's off. So it's like, I need to split this whole timeline into 4s, right? 64 frames. So that'll be whatever 64 divided by 4 is, 16. Yeah, right. Sounds about right. So for 16 frames, it will be on. For 16 frames, it'll be off. For 16 frames, it'll be on, essentially. So I need to do a little bit more math, basically. So this update gets called every single frame. And so for all that I care about, basically, this runs for 64 frames, even though it's actually just going to run as long as the game is running. So I have a way of knowing what frame it currently is. Also, by the way, Phaser actually has some like functions built in that will let you do looping animations more simply than this, but I don't entirely know how they work offhand. So this is how I would like default to doing it, because I'm used to thinking of this kind of logic in terms of using a game loop. But there are simpler ways to do this, just so you know. But we're going to do a little math. So basically, we want to figure out like, okay, is this frame 0 to 16? Is it frames 16 to 32? Or is it 32 to 48 or 48 to 64? Like which quadrant essentially is this? So the way we can do that is actually the easiest thing to do. So this update function will actually tell me, there's a way to get Phaser to tell me how much time has passed since like the total amount of time that has passed since the game started running, and also the amount of time that passed since the last frame went. But I don't actually care about either of those. I just want to know how many frames have been rendered, essentially. And I'm going to use that logic to figure out whether or not this should be on or not. So the way I can do that is by just creating here in the create thing, the create function rather, frame count variable and set it to 0. And then every time this update runs, I can say this frame count equals this frame count plus 1, essentially. So this will add up as the frames are actually rendered. I know exactly how many frames have been rendered, which is all I care about. I don't care about the exact amount of time that's like in the real world time that has passed. There's actually a quicker way to write this too. You can do plus equals 1, and that means the exact same thing. Like just add 1 to this and set it equal to that. So then what I'm going to do is I'm going to say, basically, this, essentially what I want is to do some division on the number of frames that have happened currently. So I'm going to sort of decide, like, basically, should the light be visible, right? Should blink be visible? So I'm creating a new variable called blink visible, and I'm going to say, okay, this frame count, and then you use this thing called modulo, which is basically this is like, I'm going to divide by something, and I want to get the remainder, essentially. This is a way to do some simple math. You know what? Let me just do this the simplest way possible, because like it would be better to do math here, but I don't actually have to. I could just say basically, I could just do some simple if-else logic, because I only need this to run for 64 frames. So in the interest of just like keeping this as simple as possible and not having to fumble around with math in front of all of you, I'm just going to do this a really clunky way, but it will work. So essentially, if this frame count is less than 16, or this frame count is more than 32. You know, wait, that's too complicated. Just I'm gonna make this as simple as possible. So this is an if-then block, which is really common in a lot of coding. And I'm just saying like, hey, if this is true, it's exactly what it reads in English. If this is true, do this. Otherwise, do something else. So basically, if it's less than 16, right, I'm going to have that light be off. That's going to be like the first quadrant where the light's off. So I will say, oops, I need to give this a unique name. I called it pyramid twice. Or right, blink rather. Okay. So basically, this blink set visible false. So now what we should see here if I reset this is I'm going to see it be invisible for 16 frames and then it will come on and stay on. Or not. Oh, because I never set it otherwise, right? Okay. That's why I need the else. So I need an alternate. Basically, what happened was it set it as invisible, like I wanted it to, but it never set it to visible. So I need this else block so that it can change what I just did. Okay. Let's try it now. And it broke. Okay, so now you see everything froze. I need to figure out what I just broke. Oh, haha. Okay, so here's an interesting trick. So if you are messing around with this, basically, and something goes horribly wrong, usually what you will see is just this blank image, right? It will render everything and then it'll stop. The animation loop is no longer running. So what you can do then is what I did is I opened up the console, which is somewhere in here. I use the keyboard shortcut. Okay, here we go. If you go to View and in Chrome, at least every browser has some version of this. If you go to Developer Tools or JavaScript Console under View Developer, then you'll be able to see some output from Phaser, which is trying to tell us what went wrong, essentially. So in this case,
Jumping in real quick for Windows users,
Yep.
as also for Mac users, in the top right corner of Chrome, see those three dots? If you hit those, there's a toolbar that says More Tools. Highlight on Developer Tools, and it'll open up this too.
Thank you, David. To try to make this a little bigger. So you don't need to know exactly what this means, hopefully, but essentially what it said. Man, I don't know how deep I want to get into this. This is something you see a lot in JavaScript development. Cannot read properties of undefined. This is a little confusing, but what it means is, if I go back, it does tell me at least which line it broke on. Right here, it broke on line 85. And my code editor shows me 85. And actually, if I look even more closely, it'll tell me the number of characters into that line where it broke. It broke here because I wrote blank instead of blink, essentially. And this is a no-no in JavaScript. I have this dot blank doesn't exist. So I just told JavaScript to do this set visible thing to something that didn't exist, and that breaks everything. If I said it correctly, now it works. Okay. This, of course, is the disadvantage to using a game engine for this. You have to sort of know how to read error messages, or at least how to Google them. Googling can help a lot. But anyway, so now it's doing what I want it to. Right, it's empty for a second, and then it shows up. Cool. So I want it to blink, though, right? I also want, when it's between frames 32 and 48, I want it to come back on. So I'm going to add an additional block here. So I'm trying to think of the easiest way, the way that's going to make this the most readable. Because the way I would actually do it might not be super readable to everybody. So let's say, okay, if it's less than 16, set it to visible. Else, if this frame count is more than 32, and this frame count is less than 48, so basically if it's between 32 and 48, I also want to do this. This is not how I would normally write this. I'm just trying to write it in a way that I'm hoping is the least confusing to non-developers, basically. Otherwise, at any other time, I want it to be visible. So essentially, so hopefully if this works, we'll see it blink twice. We will see it blink before we hit frame 16, and then from frame 32 to frame 48, it will also blink out of existence. Otherwise, it will be visible. Awesome. So we saw 2 blinks there, basically, and then it just stayed on. Now, if this were an actual game, that'd be a problem, but we are only rendering to the end of those 64 frames anyway, so that's all I really care about. It's just that those ones worked. Cool. All right. So now we move on to the part where we actually turn this into an image or a video, whichever one you want. This was the part that was the hardest to figure out, but I was able to find this blob of code here, which I did not create, and you don't really need to worry about. This is essentially going to take the canvas, which is rendering here. It's going to convert it into a PNG, and then it's going to create an invisible link and automatically click the link and download the image, which is a weird roundabout way to do this, but it works. So essentially, you don't have to worry about this. You just have to uncomment this stuff here. And remember, go back up to the top. We're going to change the target frame rate to low, to 2. So it's going to be moving like this now. And again, you might be able to get away with making this a little faster, but I found 2 frames a second does allow it to do the downloading and still fully render every single image without you skipping frames. So we're going to go into here. I'm going to uncomment all of this. And what this does right here is it has a total frame count. We already decided 64 frames is our total frames. That snapshot count that I mentioned before is up here. Basically, as long as we are below 64 frames, we have not yet rendered that many, then it's going to take a snapshot. That's something that's built into Phaser. It allows you to take those images out of your game, and it's going to run this code and download it, essentially. And then it's going to increment the snapshot count so that the next time a frame renders, it'll be, it'll start at 0, then it'll be 1, 2, 3, 4 until it's hit 64, and then we're done. So if all goes according to plan, cool. Maybe. Oh, yeah, okay. I have to allow this. So it was trying to block me from downloading multiple files. Chrome was just there. You might get something similar in your browser. Fortunately, it does appear to have worked. Awesome. So now we just sit here and wait. You can see it kind of slowly chugging along. Awesome. And then it stops at 64. So now those all show up just in my downloads folder. Right here at the top. So I can actually preview these. If I kind of go down through them, you should see the light come on and go back off. Cool. Now we have a series of images, and each image contains a frame of our animation. We have 64 in total. And now there's a number of ways you can deal with these images now and turn them into an animation. There's command line tools that can do that if that's something you're into. But you can also just bring them right back into Photoshop, which is probably the easiest way since Photoshop has its, sort of limited video support. Let's save this. Okay, so what I'm going to do is I'm going to go to open the file, and I'm going to click on just the first image, which is, they're all just numbered sequentially. And I'm going to just select the first image, but I'm going to select image sequence. And assuming there's not any other images in your folder that have this same convention, it'll be able to just figure out that these 64 images are all one sequence and that they are in that order. So this is probably the easiest way to do this. So I'm going to go ahead and hit open. It has this choose our frame rate. I'm going to say like 24 frames a second. That usually looks pretty good to me. But you can kind of choose whatever you want. Now, remember, you only have 64 frames. So if I pick 64 frames per second, it'll be a 1-second animation. It'll be super fast. Let's actually do 12, because I think 24 is a little too fast. It won't be quite as smooth, but that's okay. This is pixel art, so it's okay if it looks a little funny. So now when I play, it looks a little blurry here because it's just kind of previewing. It's not going to look like that when we export it, but at least I can see that, yes, in fact, this does look like I expect it to. All right. And now you just need to export it. So you can export this as a video. But if you want to see the looping really easily, we're just going to export as an animated GIF using a legacy feature that I hope they don't ever get rid of entirely. I think there's other ways to do it, but essentially if you go into export and then save for web legacy, that's where the option will be present right now. This is old stuff. I don't think they like it very much, but it's still pretty handy. So now the nice thing here is when you're saving, it'll actually show you every single color in the image you're saving. And since I did this as pixel art, there's very few colors, which is great. That's going to keep the file size very low, which also allows us to have more frames if we want to make this more complicated and also make it larger. So I'm going to make this 200% size. I usually like to make it bigger than it originally was, just to make it easier to post, because sometimes services will blow it up, but they'll make it fuzzy because they'll try to smooth it out for you, which you don't want with pixel art. You want to blow it up using nearest neighbor. Oh yeah, so that's an important thing here. Under quality, this is the method it's using to change the size. And this, if you've never done this before, if you never messed with pixel art, you probably never paid much attention to this. But if you use bicubic or one of these things down here, these are using algorithms to try to smooth out the enlarged image so it looks a little bit more natural. It doesn't look quite as jagged and strange. But again, we don't want that with pixel art. We want to see our individual pixels just blown up, just made larger. There should be no interpolation between them or anything. So that's what nearest neighbor is. It just makes it bigger. It doesn't do anything else to it. And you want to make sure the looping options are set to forever. So it will just keep looping. Otherwise, it will be very, very short. Every now and then, this doesn't work. I feel like lately it's been working, but there was a while there where I would create these and the file would loop once and stop. And I don't know why that happens. So if that does happen to you, know that it might just be a lingering Photoshop bug or just a bug with the image itself. I don't know. So we're going to go ahead and save that. And I'm just going to save it right to my desktop. And I'll call this, loop. Call it loop 1 because there's a chance this didn't work. So we'll find out. Go ahead and save that. And now when I open up my desktop, actually see it looping over here. Awesome. Okay, so I'm gonna make it bigger. Okay, so watching it here. Great. Particularly what I'm doing is I'm actually very closely watching that back layer of clouds, especially since those are the ones that I want to convincingly look like they're moving across the entire screen. And even though they're really only moving like here, and then it stops and it jumps back here, it looks like it just keeps on moving all the way across. And just like that, we have an image. It's only 180 kilobytes, so we probably could have included a lot more frames in the animation without much trouble. I know that at one point, I think Twitter or one of the platforms only allowed like 2 megabyte images for this, which is really, really small. But you can do it with pixel art. You can make a pretty complex animation that loops with less than 2 megabytes of space if you want. If you just keep the colors really limited. And again, if you want to do this on Instagram, one thing I have learned is you need to create a movie, like an MP4 file, in order to upload it, and you need to make it actually much longer than this. If you only make it like a couple of seconds long, it won't loop it. It will loop it if you make it like 12 seconds or something. So essentially, you just need to kind of copy and paste your video over and over again and make a slightly longer looping video, and then it will loop properly on Instagram. At least that's how it works as of this recording. It could easily change in the future. And that's basically it. That's the whole process pretty much. So now this file can be uploaded just about anywhere. Luckily, lots of formats still support it, and you've got your looping animation. Any questions on that? So it's for those of you who've been listening to silence, OBS is not picking up Patrick's mic, so I'm going to repeat his question back and then answer it. So go ahead, Patrick. So Patrick asks, is there, since I have this running in, this web server form, well, now it's really slow, but, in Phaser, and this can be embedded into a website, is there an advantage to exporting everything to, a looping image or a movie versus keeping it just in Phaser and just hosting it somewhere? Not necessarily. To me, the advantage of the the image or movie file is that it's just extremely portable. You can text it to somebody, it'll work. It just like works. And if all you're doing is looping an animation, I don't see much reason, especially if it's pixel art, which is kind of this format is really, really well designed for, then I don't see much of a reason to just do it in Phaser. But you certainly could, if you wanted something more complex, if you wanted it to be interactive, of course, then Phaser would be great for that. If you wanted, so when I click on it, like fireworks go off or something, Phaser could allow that. The only trick is that if you were to host this, you can't just put this anywhere. You need to put it somewhere that's running JavaScript, and specifically that has a canvas element in the page too. So, I mean, pretty much every browser supports Canvas. It's pretty old at this point, but there's a lot of requirements under the hood for Phaser to run smoothly, even though it is a very, like, it's a mature and pretty well supported game engine. But you need to put it somewhere like that can host it properly. So either on your own server, or you could run it. You could run it on GitHub pages, actually, I guess, or you could run it on itch.io, something like that. But you have more limited options in terms of where it can sit. So that would be, the difference between sticking to the game engine versus exporting it. Sure, Patrick. Thank me for the answer. So you had a question?
I was just curious, that part of your code where you wrote the nested if-then statements, yes, that is totally the kind of code that I would write. And so I was, sorry, if-else statements, sorry. I was curious, you said that you would write it differently. So I
Now I
thought,
have to do it. Okay.
if that's okay.
Sure, I just
or
didn't
if
want you.
it's so complicated that I won't understand it, then never mind.
No,
But
no, no. I just
yeah,
didn't want you. It's more.
curious.
I knew it was like, oh wait, I didn't prepare this part, so I didn't want to have you see me fumbling through it. But let's try to figure this out. So what I want is basically, I want to know is this code divisible by? So okay, think of it this way: if we did it every other frame, this would be very simple. I would just simply say, is this number, the frame count, evenly divisible by 2? And then on one frame it would be yes. On the next frame we no, because like frame 1, no. Frame 2, yes. Frame 3, no. Frame 4, yes. That's what I want. I just need to do a little bit of math to make that work on a 16 frame
Yeah,
cycle.
what character did you type to get the modulo?
The percent sign.
Oh, okay.
So I guess I can show you that right now, right? If actually what I could do is even simpler than that. I can just say this blink set visible. And since this takes either true or false, I can just take this, which evaluates to either true or false. Anything in an if block does. And I can just put it right in there. And then I have one line of code. So what this is going to, so now I can delete all this, and I can just do this. And what this is saying is, okay, set blink to either visible, so set its visibility, property to either true or false based on whether this frame count is evenly divisible by 2. So basically what this means, oh, no, sorry. I need to do this. Okay. So what I want to say is modulo is going to give me the remainder, basically, right? I want that to be 0, meaning it is evenly divisible by 2. This double equals here is important. So I'm saying, like, I want this to evaluate to true or false. If I just put equals, though, I'm trying to tell JavaScript now, set this equal to 0, the same way I'm doing, like, this right here. So inside an if block or like a true false block, you need to do double equal signs. And actually in JavaScript, there's triple equal signs, but I'm not going to do that now with that. So essentially, this is going to make it blink really, really fast, but it will do it every other frame, essentially, if I'm doing this correctly. So let's find out. And I'm going to set this back to, I can set it back to, I can keep it on. Oops, wait, no, stop. I need to comment out this again. It's starting to re-download everything. Let's comment you out. Okay. Now, open that up again. Oops. Okay. All right, here we go. So yes, now you can see, since we're only doing 2 frames a second, you can clearly see every other frame it goes on. But it does work, right? This will loop endlessly. It's very simple. So now what I need is, I don't actually want it to be if it's divisible by, I think what I could do is, okay, if it's I could divide it by 16. and I want this not to be 0, but I want it to be less than 6. Wait, I'm trying to think. See, I have to do the math here, right? So like, I want this something to be true for frames 0 through 15, but then stops being true at frame 16 and starts being true again at frame 32, and so on and so forth. So what I want to say is, if I divide this by 16, right, and it's less than 16, then
But you're still going to get remainders throughout the
right.
last quarters.
How do you do this? Okay, I know there's a way to do this. Hang on. So the other way is probably through some multiplication here, essentially, right? Like,
Wasn't paying full attention. What was the math problem?
hey, math person. So, Mr. Guizdala, how would you set this up so that we basically want to say like, okay, every 16 frames, this should be like on a 16 frame loop, this should go from true to false.
And it's modulo of 16.
That's it?
Yeah.
Oh.
So what modulo does is it divides by that element
Uh-huh.
and returns the remainder. So if you modulo it by the value you're looking
Okay,
for,
but here's the problem. See, what's going on is it only comes on for one frame. I want it to come on for 16 frames. So basically, it's like I want to stretch out time here. I want to do from 0 to 15, there should be, it should be gone. Then from 16 to 31, it should be visible. Then from 32 to 47, it should be gone. And then from
so
48,
every other 16?
yes. Like I want it to stay on for 16 frames, then go
That's
off.
fine. Then have a Boolean value that's set every time your modulo of 16 equals 0.
Ah. Very clever.
So for everybody else here, Quinn is going to be defining a constant that is a Boolean. Boolean is a true-false statement, which is indicating whether or not he wants the light to be on or off. What he's going to do is have that true-false statement evaluate itself against a context that we're creating here. And essentially, if that value flips, then we're going to be changing the value of blink visible. So when we see 16 to true, flip blink visible.
So it's like a little switch.
Yeah, exactly. Oops. That's actually exactly what a Boolean is. It is literally on
You
or off.
probably don't want to set it to equal to false.
Yep.
What you'll want to do is set it equal to not itself.
Negative itself. Yes, thank you, friend.
Do a whack instead of a minus, because it's a Boolean. Thank you. Exclamation point
I
is a
didn't want
whack.
to do this because it makes me look like an idiot. Yes, thank you, friend. All right.
Sorry, we can get Patrick to take it out, but I was very curious.
And you know what?
No, these are good questions.
No, and also like this is like software development. I somehow get paid a lot of money for this, even though I'm terrible at it. We're all terrible at
Yes, that's 100% true, and I'm terrified for the state of the world.
it. All right.
I can't imagine how you don't end up with so many typos. All the typos that you had, I didn't see them until
Well, they just
it was
don't work,
too late. Yeah.
right? Like the annoying thing about JavaScript is that it will it kind of just tries to keep going. It kind of tries to paper over the issues you're having, like, and not tell you anything's wrong and just hope that it works out. So it's actually, unfortunately, not a great language to start learning with, even though it's the most widely used and accessible one. So other languages will just fail. Well, they won't even compile. They won't even run, like, until, because like, hey, like that thing I did before where I changed this blank set visible and now it's going to crash, right?
Yeah.
Now there's tools that keep you from doing this. There's a thing called TypeScript, which sits on top of JavaScript, and if I were using that here, it would underline this in red and say, "Hey, you didn't define this," and then I would know, "Oh, whoops," and I would go back and change it, and then I didn't, like. And a lot of languages would never even start running this. They would go through it and they go da 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 da, like, "Oh wait, what's this dot blank? That doesn't exist. I'm not running." So that's called a compile time error, and those are usually helpful and like tell you exactly what's wrong. Versus what happened here, which is a runtime error, which are often unhelpful and confusing unless you know what you're looking at. The problem with JavaScript is like it just tries to keep going. It's like, well, this doesn't exist, but all right, I'm going to try to set it to visible, even though it doesn't exist. And then it crashes because you can't do that. So, little fun fact. Meanwhile, like, yeah, I work in JavaScript or TypeScript like all day, every day. I have to deal with this all the time.
So Quinn,
Mhm.
there may be a way that you can speed up your GIF making process even faster.
Oh yeah,
Uh, after you download the images to a folder, you could execute a library that converts to GIF.
yeah. Actually, I have a little note in here that you can do that with ImageMagick.
Yep, that's the one that I was going to recommend. I didn't
Yep.
even see it in there. Yeah.
I didn't want to get into that because I don't know how many people here want to goof around with command line stuff, but
Okay, cool.
but
Just wanted
yeah,
to make sure you got that instead of the Photoshop one because that's significantly slower than ImageMagick.
yes, this is actually really nice. So yeah, there's a really simple tool you can download that runs on a command line, and it seems a little scary at first, but it lets you do stuff like this where you just create it with a simple little command like this. There's also something called FFmpeg, which will let you create videos the same way. But you have to get familiar with their syntax. So it's there's a little bit of a learning curve there, but they are quite powerful tools. They're totally free, and they're very, very handy.
I just
So
posted a link to that in the chat.
awesome, thank you.
Mhm.
Cool. Yeah. So, any other questions, comments, concerns?
What's the command line one?
It's called ImageMagick, and
Oh,
it's in. I posted the link to this thing, so you can look it up there. But that basically, ImageMagick has this wonderful old school. Well, it's not quite as old school as it used to be. It's still pretty old. I just like this. Still feels very old fashioned. This website here, but they'll tell you all about how to use it, and I believe it's cross platform. I've only ever used it on a Mac, but I'm sure you can get it working somehow. But yeah, it's very cool.
and FFmpeg?
FFmpeg is the other one. Yeah, this is much newer and fancier looking, but well, not that fancy. But yeah, you can do stuff like this. This is just converting one kind of file to another, but it's similar. Yeah, these are both command line tools that have tons and tons of graphic features in them, and you can connect them to like when when your favorite platform or whatever is letting you like mess around with you upload images and it lets you like edit them and add like filters and stuff like that. It's probably using something like either this or something very much like it in the background.
Awfully neato.
Yeah, it's super neat. All right. Well, if there are no other questions, thanks everybody for coming. I hope this was illuminating. And yeah, if you do any of this stuff, if you want to mess with it, please please show it to me because I want to see if this actually works for anyone. I don't. This might just be like a workflow that only makes sense to me, but if it's helpful to other people, that would make me very happy.